Assalamualaikum dear viewers, Shoaib and Dayo is here with a new lecture of the electrical machine subject, and today's topic of our electrical machine subject is autotransformer. And in our previous videos of the transformer, we have done the two winding transformer lectures. Now we are covering the autotransformer, which is normally a single winding transformer. So as you can see from the board, the topic is written over here is the autotransformer. And what is the autotransformer? Let's discuss. An autotransformer is a single winding on an iron core, and a part of winding is common to both primary and the secondary winding. It is a single winding transformer. It is a single winding transformer, and the part of that winding is common to that primary section and the secondary section. So as you can see the two diagrams, here this diagram is the step down autotransformer and this diagram is the step up autotransformer. Now step down autotransformer is that here the voltage is step down into the HV is into the LV, and here this in the step up transformer, okay, here this one is the LV side and this one is the HV side. Now here HV side is the high voltage side and LV side is the low voltage side. So in the step down auto transformer, the higher voltage is step down into the lower voltage, and in the step up transformer, the lower voltage is step up into the higher voltages. So as you can see on the board, figure 1 and 2 shows the step down transformer and step up auto transformer. Now in both cases, the winding AB having N1 turns. This one is the A and the B, and this is the A and the B. Now here A and the B are connected with the HV side, okay, and here again this A and the B are connected with the LV side. Even in the A and the B are connected with the HV side in the case of the step down auto transformer, and in the case of the step up auto transformer, this A and the B portion is connected with the LV side. So in both cases, either step up transformer, auto transformer, or step down auto transformer, the winding AB has the N1 turns, okay, and which is called as the primary winding, okay. You can see on the both cases the AB portion is the primary winding portion, either it is a step up transformer or a step down transformer, okay, and the BC portion having the N2 turns is the secondary winding. As you can see, this one in the case of a step down transformer, this BC portion, okay, is the secondary side low voltage portion, okay, and here in this step up auto transformer, here BC portion is the HV side portion. So summarize these figures, the A and the B in the both cases of the step up or step down transformer are connected with the primary side, and the B and the C portions in the auto transformer are considered as the secondary side windings or having the N2 turns, okay, either it is a step up transformer or a step down auto transformer, okay. Now the primary and the secondary windings are connected electrically and as well as magnetically. Now differentiate the two winding transformer with this auto transformer. In the two winding transformer, there are the two windings of the transformer, both are magnetically coupled but electrically isolated. But here in the auto transformer, the both primary and the secondary winding are physically electrically connected and also the magnetically coupled. So this is the beauty of the auto transformer, is that the both windings, the primary and the secondary windings, are electrically and the magnetically coupled, but the two winding transformer is the electrically isolated but magnetically coupled, okay. Power from the primary of the transformer is transferred to the secondary by conductively and as well as inductively, because in the auto transformer the both windings are electrically and magnetically connected. Obviously, the windings, the power in the auto transformer, either in the both cases of the step down or step up auto transformer, the power is transferred within the windings is conductively and the inductively transferred. Okay. Now, the voltage transformation ratio is the same as that of the two winding transformer. K is equal to that voltage transformation ratio is the V2 over V1 is equal to N2 over N1 is equal to I1 over I2. From this expression, we can conclude that the transformers are non-linear in behavior. If the voltage is high, the current is low, and if the current is high, the voltage is low. Okay. Now, in this condition, the voltage in the transformation ratio, the voltage is directly proportional with the number of the turns of the coil. If you are increasing the number of the turns of the coil, then the voltage will be induced more in the windings of the transformer, in the core of the transformer. Okay. And what about the current? The current is inversely proportional with the voltages. So, this shows the transformer is a non-linear in behavior. Okay. Now, see these diagrams. Now, this was the unloaded condition of the auto transformer. Okay. And now, both these cases are the loaded auto transformer cases. Okay. Now, this is the loaded step down auto transformer and this is the loaded step up transformer. How we can say that it is loaded? Because load is connected with the secondary winding of the transformer. Again I am going to repeat that this one is again A, B and the C. Here A and the B portion is common to that, like connected with the primary side, and here primary is the HV side. Okay. And the B and the C portion having the N2 turns is connected with the LV side. Okay. And here V2 is the output voltage and V1 is the input voltage. So, here HV is stepped down into the low voltage, and here again in this diagram is this one is the A point, okay, C and the B. Here again A and the B are connected with the primary side of the auto transformer and the B and the C are connected with the secondary side of the auto transformer, and the load is connected on the both secondary side of the transformer, auto transformer. Either it is a step down or either it is a step up auto transformer. Okay. Now, in both cases I1 is the input current, as you can see. In the both cases, in the step down transformer you can see this one is the I1 is the input current, and here again in the step up transformer I1 is the input current. Okay. I2 is the output current or the load current on the in the both cases, as you can see. In the step down transformer, here I2 is the secondary current, and again here is the I2 is the secondary current which is in the step up auto transformer, and here I2 is in the step down auto transformer. Okay. For both connections, the current is common in the portion of the windings of the primary and the secondary is the difference of that currents. Okay. Now, current in the common portions of that in the primary and the secondary will be the difference of that currents. So, the relative direction of the current through the common portion of the winding depends upon the connection of the transformer. Here, the relative direction of the flowing of the current either in the step down or either it is in the step up transformer, it depends upon the number of the connections of the auto transformer, either it is a step down transformer or either it is a step up auto transformer. So, for the step down auto transformer, the I2 current is greater than I1 current, so that I2 here the difference of the two currents is the I2 minus I1. Consider this loaded auto transformer step down loaded figure. Here the voltage is step down from the higher value to the lower value. Okay. Now, recall the concepts of the non-linear circuits. Here the I2 current, because here this is one is the low voltage side portion. So what is the property transformation ratio? According to the transformation ratio of the transformer, voltage is inversely proportional to the current. So here voltage is lower, the current will be upper, current will be high. So if the current will be high, so here in the loaded step down transformer, the I2 current is greater than the input current. So here this will be written as I2 minus I1 current flows through the common portion of the windings of the transformer in the case of the loaded step down auto transformer. Here in the loaded step down auto transformer, the secondary side voltage is the low voltage and the current is the I2. So here in the loaded step down transformer, the I2 current is the greater one, and because the voltage is the lower one. Okay. And step up transformer, okay. Now in the step up transformer, auto transformer, the I2 is less than I1. Okay. As you can see from the diagram, here the secondary winding, which is the B and the C part of that winding, okay, is the high voltage winding, and here I2 current is flowing. Now this I2 current is the less than the I1, because the I2 current in the high voltage winding, so here the voltage is high, so I2 current will be low. So here I2 is less than the I1. So here the difference of the current in the step up auto transformer is the I1 minus I2, and here in the step down auto transformer, here the difference of the current is the I2 minus I1. So this I2 minus I1 or I1 minus I2 shows the relative direction of the flowing of the current from the windings of the transformer. So it depends upon the connections of the transformer, that either it is step up auto transformer or step down auto transformer. For the ideal transformer, transformation ratio is equal to 1. So all the your current flow through the exciting current and the losses. In the case of the ideal transformer, I have put the lecture of the ideal transformer in the transformer playlist. You can find out the lecture that ideal transformer has no any winding resistance, leakage reactances, and no any losses. So transformation ratio for the ideal condition is the 1, K is equal to 1. Okay, so this will be the negligible. Now what are the advantages of the auto transformer? Advantages of the auto transformer is that, first, it requires the less number of the copper in comparison to that two windings of the transformer. Obviously, in the case of the auto transformer, we are using only one winding, single winding, which is common to the both primary and the secondary winding. And in the two winding the transformer, obviously the primary is the separate, secondary is the separate. We require the more number of the copper wires, more number of the windings of the turns of the wire. So in the case of the auto transformer, we are requiring the less copper wire in comparison to the two winding transformer. This is an advantage of the auto transformer. It has the better voltage regulation, okay. It is smaller in size in comparison to that two winding transformer. Obviously, we are using the two single winding. Obviously, the size of the transformer is the less one, is the lower one in comparison to that two winding transformer. It requires small exciting current. So these are the advantages of the auto transformer. Let's discuss the disadvantages of the auto transformer, okay. And now as you can see, first disadvantage is that there is a direct connection between the primary and the secondary, okay. In the auto transformer, there is a common portion of the primary and the secondary winding of that Rn core, and both primary and the secondary windings are electrically and as well as magnetically coupled, okay. Now in the two winding transformer, as you can see, okay, this is the two winding transformer. For example, the both windings, primary and the secondary windings, are electrically isolated but magnetically coupled. So the first disadvantage is that there is a direct connection in between primary and the secondary in the case of the auto transformer. So means there is no any isolation between the primary and the secondary of the transformer. So this is the first disadvantage, okay. Number second is that an auto transformer is not safe for stepping down the high voltage to a low voltage. Consider this figure. Here 11 kV is applied to the primary winding of the auto transformer, and here this is the case of the step down, okay, loaded transformer, step down loaded transformer. Here we are supplying the 11 kV to the primary winding of the transformer. 11 kV means 11,000 volts, and you are getting the 230 volts, okay, from the secondary winding of the transformer. Here 2 and the 3 portion is the secondary winding portion or the load side portion, okay. If an open circuit it develops in the common portion of the 2 and the 3 due to any reason, if the open circuit is developed in this 2 to 3 portion, load side portion or the secondary side portion, now the full load voltage 11 kV, 11,000 volt will appear across this 230 volt side, your low voltage side. So this one is very dangerous for both personnel, for both persons and also the equipment. Why? Because total 11 kV, total primary voltage will appear across the load side, low voltage side. So this will be very dangerous, because here why this 11 kV, why this high voltage will appear across the load side? Because the primary and the secondary of the auto transformer both are connected on in same iron core, and so that's why there is no any isolation between these two windings. So your step down loaded transformer, okay, means auto transformer is not safe for stepping down the high voltage to the low voltage, okay. So this is the another disadvantage of the auto transformer. Number third, the short circuit current is much larger than the two windings transformer of the same rating. Again, so auto transformer has the primary and the secondary winding, okay, with the common portion and on a same iron core, because there is no any isolation between this primary and the secondary winding. And again in the two winding transformer there is an isolation between the primary and the secondary winding. So if short circuited is occur in secondary side, then obviously what happened, your primary will also be short circuited, because both windings are physically connected, both windings are electrically connected. So this reduces the effective reactances and resistances in the transformer. As you know, the short circuit current is the abnormal current which is occur in the power system due to the at the short circuit point the reactance of the system is very much low, and the potential at the fault point where the fault is occur in the power system is equal to that 0, which is earth potential, okay. Now let's discuss the application of the auto transformer. Number first is that the auto transformer are used for voltage, compensate the voltage drop in the transmission and the distribution line. So they are also called as the booster transformers. So transformers are also used for the compensation of the voltages in the distribution and the transmission systems. So to boost the voltage, okay, where they are required, so that is called as the booster transformer, okay. Second is that the auto transformer is also are used for reducing the voltage supply to the AC motors during the starting period. So they are also used for reducing the AC voltage during the static period of the AC induction motors. Number third is that auto transformer are used for variable continuously supply in electrical testing laboratory. For example, in the machines laboratory, so we have a different equipments, okay, they are working on the different voltages. For example, this is the transformer, okay, and here is the 127 voltage winding and there is a 50 voltage winding. See, if there is a high voltage winding and this is the low voltage winding, if you are stepping down this voltage from 127 to 50 volts, so this one is the primary winding and this one is the secondary winding, okay. Now we have a fixed supply from the main supply of the any trainer or any supply side. So the supply is the fixed one, which is the 221. Okay. Now how you can vary the amount of the supply to become the 127 volt, because here we are required the 127, we can't exceed the voltage from the beyond the 127 volts. So we have a 220 single phase supply, so we need variable auto transformer, okay, to maintain or to regulate the amount of the voltage as the voltage which is to be under the permissible limits of any electrical machines or any electrical equipment, so that we can operate the voltage according to the desirable amount of prescribed limits of that voltage which are mentioned on the electrical machines or any electrical equipment. So these auto transformer are used for continuous variable supply in the electrical testing laboratories to regulate the voltage which is sufficient or which is used for the any electrical machines that are operating on the different voltages. Okay. So this was the application and the disadvantages of the auto transformer, and we have discussed the advantages and the working of the auto transformer in our today's lecture. So I hope that you have enjoyed the today's lecture, and at the last, please don't forget to subscribe my YouTube channel Shoaib Ahmed Dayo for more informative videos related to the electrical engineering area. Thank you.